Okay, we should be on. Okay, so welcome to Math 11. Today we're going to be looking at just reviewing something you've seen probably in middle school or grade 9, reviewed Pythagorean theorem. And we're going to just solve some basic problems using Pythagoras. The reason why we do this is because the first unit we're going to be looking at in Math 11 is trigonometry. And trigonometry deals with right triangles. Sometimes you can solve things using Pythagoras, and sometimes you have to use trig functions like SOHCAHTOA, which I'll talk about tomorrow. So Pythagorean theorem, does anybody remember what that is? Can you just tell me what it is, Brianna? Sorry, I'm getting to know you. That's right. A squared plus b squared equals c squared. So what we have to do is put those in the context of a triangle. So we're going to look at triangles. Remember, we're only dealing with right triangles. A right triangle has one angle that is 90 degrees. The other ones could be any other, but you can see here it's probably going to be, since this is 90, so you remember what all three angles add up to. If we were to take all three angles here and add this one and this one and this one, they will all add up to 180 degrees. All triangles, the three angles, no matter if they're right or if they're acute or if they're obtuse, all the angles will add up to 180. So if this one is 90, then these two have to add up to 90. 90 degrees plus 90. So we know one is already 90. So the other two have to add up to 90. That could be 30 plus 60. Could be 20 plus 70. Could be 10 plus 80. Any combination, long as they add up to 90. So all three add up to 180 degrees. That's one of the laws of triangles. All the angles equal 180. So, like Brianna said, when we look at a triangle, we have to designate the sides. So going back to the first, one of the standards we use in math, let's leave that there, is we label triangles with letters. So if we take a corner where we're going to have an angle, we'll label that with a letter. We use uppercase letters. That's the standard. Big letters, uppercase, capital letters. This one here, C, and this one, B. Okay, I could have put A here, and I could have put B there. It doesn't really matter. Once you do that, remember that the sides are opposite the angles. So if I look at this angle here, the side that's opposite is over here. So that's side A, and we use a lowercase for the side. This is angle C. The side that's opposite it here is small c. And here is angle B, and the side that's opposite that, going from here, this is the angle, this is side B. So that's how we get the letters A, B, and C, where we use in Pythagoras theorem. So here I have side C, A, and B. Now, we know that a square is a figure that has 4 equal sides. So if I took this side A here in the triangle, this is my triangle, if I just took one side and I made a square, then the other side is going to be the same length, and the same length, and the same length. So they're all the same. And so if this side is A, and this side is A, and this side is A, and this side is A, they're all equal. And to get the area of that is A times A, which is A squared. So this side is A, this side is B. So that means I have a square for all equal sides B. So that makes this square b squared. That's a b, that's a b, that's a b, and that's a b. And if I took the area of it, it's b squared. And finally, if I take side C in the triangle, C in my triangle, and then make a square of it, I have c squared. Now you can almost see that this square and this square, if you were to add them together, they'd be the same amount of space as that one. So visually we can appreciate that c squared is equal to a squared plus b squared. So we can write that. C squared is equal to a squared plus b squared. That's Pythagoras' theorem. The side, the longest side, the square of the longest side is equal to the sum of the squares of the other two sides. Not the sides, but the squares of the sides. Okay? It doesn't, this is not right. That's wrong. It's c squared equals a squared plus b squared. That's Pythagoras. Okay? So Pythagoras' theorem is either written as a squared plus b squared equals c squared. Now, if we only want to find what c is, now we have to develop a formula. How do we get just to find the side? Not the whole square, but the side. Well, if I look at that and I'd say, okay, what does c squared equal? Well, what does 2 squared equal? 2 squared is 2 times 2, right? Any number that's squared is that number multiplied by itself. So c squared is c times c. And what that is means, and you've learned before what square roots are. So if I take the square root, that sign here means square root. If I take the square root of that, it's c. It's asking me what number multiplied by itself will give me this. Well, that's c. What is the square root of 4? Well, that's 2, because 2 times 2 is equal to 4. Or 2 squared is equal to 4. And same thing here, c times c is equal to c squared. Therefore, the square root of c squared is equal to c. You see the pattern? Okay, so we know that from Pythagoras, c squared is equal to a squared plus b squared. I just want to find c. In order to find c, I have to take the square root of it. Whatever you do to one side, you have to do to the other. So if I take the square root of this side of the equal sign, I have to do the same to the other side. Okay? If I were to multiply this side by 2, just as an example, let's say I had c squared plus a squared. You write this? Okay? There's my equality. Now let's say I want to double that. I say, okay, what is 2c squared? Well, if I put 2 here, it means I have to have 2 of this and 2 of this. Whatever I do to one side, I have to do the other. So I could write it like this, or I could write it like, just make it into brackets. It means everything in here is multiplied by 2. So if this is multiplied by 2, this has to multiply by 2. So if I take the square root of this, I have to take the square root of this. That's the same thing as saying okay? I can either write it separately or put both of them underneath it. It's the same thing. So now we have something we can write. We know that the square root of c squared is c, because c times c makes c squared. So if I take the square root, it's c. So now I can write it like this. C is the square root of a squared plus b squared. Very important. A squared plus b squared. Now, take it one step further. Let's start with Pythagoras again. C squared equals A squared plus B squared. Let's say we only want to find A squared. If I only want to know what this is, what do I have to do? I have to get rid of this. So, if I want to get rid of this, I have to take it away. B squared minus B squared is going to be, they cancel out, right? So if I do it over here, I have to do it the same thing over here. Whatever I do to one side, I have to do to the other. So now I'm left with just A squared. So that means C squared minus B squared is equal to A squared. What's A going to be? Well, if we take the square root of this, means we have to take the square root of this. So that means, and the square root of A squared is A, because remember, A times A is equal to A squared. And the square root of A squared will equal A. So A is equal to the square root of C squared minus B squared. And you can do the same thing for B. By the way, I can write it like this too. I can just switch sides. That's the same thing. You all agree? Doesn't matter which side you want, as long as you don't lose any of the numbers or the unknowns. So now, if I only want to find out what B squared is, or sorry, A squared, it means I got to get rid of this. So, it means I have to subtract it here, which means I have to subtract it over here too. So now, B plus B minus negative B, that cancels out. So I'm left with A squared is equal to C squared minus B squared. Then take the square root of A squared, which means I have to do the same over here. And then the square root of A squared is going to be A equals, I can't solve this right now, I can just leave it like that until I get numbers. And once I have numbers, I can put that in there and solve it. So that's how we get the formulas. So, here, if we look at the sides, this is A, which means that angle A is side A. Angle C, side C. Angle B, side B. Just go to the opposite sides. Same thing here. So I can write C is equal to square root now of A squared plus B squared. I can write A is equal to square root of C squared minus B squared. And I can write B is equal to C squared minus A squared. So the big side, the long side, is always adding them, but the smaller ones, the legs, is when you subtract them. We just varied Pythagoras' theorem from when it was just a basic addition okay, when C squared is equal to A squared plus B squared. We wanted to find out what A was. What's this side? A. It is C squared minus B squared. And if we're looking for, this is where we're looking for A this time, I'll put the blue. That's the right angle. I'm looking for B this time. So B is going to equal to the square of the big side minus the small side. So let's look at it in practicality. It makes more sense sometimes we put some numbers into there. Here we have an example where they're trying to build a roof and they want to know the length of the unknown. So what we have here, we don't know the length of this part of the roof. Okay? They tell us that this height here is 5 feet, this height here, and the length here is 10 feet. So we have two sides. If we got two sides, we can use Pythagoras. So we make that as a triangle. Let's go down, get a little lower. So there's my triangle here. I draw my triangle. There's my right angle. They tell me that the height is 5 feet. They tell me that the length of this one is 10 feet. And they want to know what the length of that top beam is. So I say, well, now I can use Pythagoras. I have three sides. So I can say, okay, this is my side C, this is my side A, and this is my side B. So I'm going to look at this. That's my unknown. Here we got this side over here, B, and opposite the A here. So if I write Pythagoras, C squared is equal to A squared plus B squared. C squared, I don't know, is going to be A squared. Well, A, we already said here, is 10 feet squared. 10 feet squared, because it's A squared. And B, we have our B side, is 5 feet. So plus 5 feet squared. So we got up our formula set up. We want to know what C is. Well, if we just keep it like that, C squared, say we don't really want to go there so far. 10 squared is what? 10 times 10? 100 feet squared. When you multiply feet by feet, you get feet squared. Then you are you using that or just your notes? You okay? 5 times 5, 25 feet squared, right? Now, add them together. 100 plus 25. 125. So we know C squared equals 125 feet squared. We don't want to know C squared, we want to know what C is. It means we have to take the square root of that. It means we have to take the square root of this too then. Whatever we do to one side, we do to the other. So, square root of C squared is C. We look in our calculator. I'm going to get one here. Square root of 125. Oops, I put my thing here. There we go. 1, 2, 5. Oops, clear that. Too many numbers. Where's the clear? Right here. 1, 2, 5. 125. I look for the square root sign. They don't have one now, so I need a scientific one. Oh, here it is right there. Square root sign. And I got 11.18. Look at all those numbers. Well, we don't have to write all of those. I'm just going to write the 1, 11.18. And if I want to go to one place, since this is a 1 and this is an 8, it's 5 or bigger, I can write it as 11.2 feet. So my C side, or my top beam, is 11.2 feet. We use Pythagoras to solve it. Okay. All right. So I'm going to give you some worksheets. I've got them in my package. I'll send these home as well for the home support students. If you're in the A group, you'll be doing these ones. You'll see it on the, and I'll hand you the ones that you need. This will be in your Dropbox. If you're in the C group, these ones will be in your Dropbox. So there's going to be either 4 to 5 sheets are in there with just triangles for Pythagoras solutions. And that's it.